So in this section, we're discussing order of operations, and in my humble opinion, out of everything that you could ever learn in math or algebra, the order of operations is the most important piece of information you could learn. Order of operations tells you how to go about evaluating and simplifying an expression, a mathematical expression. And you have to have an order to do that, otherwise you're bouncing all over the expression and solving it however you want to, and you could come up with several different answers. It's kind of like I equate it to reading, where we learn that we always start at the top left-hand corner of what we're reading, and we read left to right, top to bottom. In mathematics, we don't always start on the left and go left to right. We have to use a different order for that. And there's a pretty famous acronym in math that we use that's PEMDAS. And lots of people say PEMDAS. Some of you may have heard, "Please excuse my dear Aunt Sally." And it kind of helps you remember the order of operations. It's a decent way to remember it. It has a couple flaws that I'll go over. So the first kind of zone of the order of operations, I'll draw a line there, is the P. The first thing you simplify an expression is the parentheses. P stands for parentheses. Now, I am along the lines that I want to change the P to a G. And I want it to stand for grouping symbols, because it's not just about parentheses. It's about parentheses and brackets and braces and the fraction bar and the square root symbol. Those are all grouping symbols, and you simplify things within those grouping symbols first. And you simplify them according to the order of operations. The next section of order of operations that you do or you look at is exponents. So you simplify all your exponents. Any base number to the power of something you're going to simplify. And then you move on to the next area of order of operations. Now it's not the M. It's the M and the D together. You need to read it rather than, some people say multiply and divide. I want you to be very careful that you multiply or divide, whichever comes first. That gets people into trouble when they think that the M is there, so I need to multiply first. But it is really saying that you need to multiply or divide whichever comes first. So you do this left to right, whichever is first. So if division comes first, for example, if we had 6 divided by 3 times 12, we're going to do the 6 divided by 3 first. Then we do 3 times 12. We're not going to do 3 times 12 and then do the division, all right? So we would do the division first because it comes first. If it said 3 times 12 divided by 6, then we would do the multiplication first. So whichever comes first. And the add or subtract, that's the same thing. You're going to add or subtract whichever comes first. And this area goes away after a while, because when we learn about real numbers and positive and negative numbers, pretty much what we do is we start looking at terms, and it isn't about adding or subtracting anymore. It's just about combining terms, and so subtraction basically goes away because it's the same as adding a negative. But for now, when you see addition and subtraction, you're going to do the same thing. If you see 6 minus 3 plus 2, you're going to take 6 minus 3 first and add 2. Or likewise, if you saw 3 plus 2 minus 6, you're going to do 3 plus 2 first and then take away 6. So order of operations, please excuse my dear Aunt Sally. I want to change it to G, excuse my dear Aunt Sally, I guess, for grouping symbols. That's going to help you do expressions. So let's put up a couple of different expressions to simplify and follow this order of operations. So a lot of times in algebra books, they're going to say evaluate, and they're going to give you an expression. Now, evaluate just means, simplify it, solve it. It's another word for just doing the work in mathematics. It doesn't mean write something about it. I say that because one of my students did that one time. I had it on a test to evaluate something, and they wrote me a paragraph about the information. So you're probably laughing right now. It's true. So I always remind my students, evaluate means to simplify or solve an expression. So we have 15 divided by 3 times 6 minus 4 to the second power. So according to order of operations, our Pemdas, we don't have any grouping symbols going on here, so we don't need to simplify those first. So the next thing we move over, the E, the exponents, we're going to simplify this 4 to the second power and make it 16. Now I remind my students, once you do that, go ahead and pull everything else down that's left on the expression. So we're going to pull down the minus sign, the 6, the multiplication, the 3, the division, and the 15. So now it reads 15 divided by 3 times 6 minus 16. Now we take a look at that expression. Well, we see that 15 divided by 3 comes first, so we're going to do that first because it's multiply or divide, whichever comes first. So 15 divided by 3 is 5. And again, we're going to rewrite the rest of the expression so we have a times and a 6 and a minus 16 left. Now we do the multiplication because we got to do multiplication before we do addition or subtraction. So we have 5 times 6 is 30, and 30 minus 16, we pull that rest of that down, and we finish it out. 30 minus 16 is 14. Now let's evaluate another expression. We have 32 plus 7 squared minus 5 times 2. And in this situation, I want to show you where you can kind of combine, you can combine a couple of terms, a couple of operations, because we're keeping them in the term of terms. And what I mean by when I say terms is when you look at an expression, everywhere you have a plus or a minus, you've created a situation where you've created a term. So 32 is a term, 7 squared is a term, and 5 times 2 is a term. So in the order of operations, it says, okay, we need to do grouping symbols. There's no grouping symbols in this. Then we need to do exponents next, and then we need to multiply or divide and add or subtract. Well, we can, in this situation, we can do this 7 squared and the 5 times the 2 at the same time if you want to save a little space and speed yourself up a little bit, because that minus symbol, that minus sign, has separated those two and created them into terms. And so doing them does not mess up or reflect upon any operation between the two if we're doing them at the same time. If I do 7 squared first and then I go and do 5 times 2 next, well, I'm still going to have them separated by that minus, and it's still going to remain the same answer. So speed yourself up a little bit. You can do 7 squared is 49, and then 5 times 2 is 10. Pull down that minus sign, pull down the plus sign, and the 32 there, that first term. And now you have 32 plus 49 minus 10. Now you're going to add or subtract, left to right, whichever comes first. So we're going to do the 32 plus 49. Let's see if I can do a little mental math. 49 and 2 is 51, and 3 is 81. Another way you could do it is 49 is close to 50. 50 plus 32 is 82, and what did you add to 49 to get 50? A 1, so you got to take that away from the 82 to get 81. Sometimes people do that to do some mental math. And I pull down the minus, and I pull down the 10, and then 81 minus 10 is 71. Now let's evaluate an expression that's going to use some parentheses and kind of talk about how that kind of changes things up and how you have to think about order of operations with some grouping symbols and how not to kind of jump to, oh my gosh, there's a parentheses and I have to do something. I just wrote up here 2 open paren 5 close paren plus 3 open paren 4 plus 3 close paren. Now the 2 open paren 5 close paren, some people want to jump to that and go, oh, parentheses, I got to do something with the 5. Well, all that is doing is separating that 5 and putting next to the 2. That's another symbol, another way of saying multiplication. So when you see the 5 within the parentheses, you need to remind yourself there's nothing to do to the 5. It's just separating it out and reminding you that it's multiplying by 2. Now some people say, well, why do we use the parentheses? Why don't we use the dot or the times symbol? Well, parentheses are cleaner and make sure that the writer and the reader know that it means times. If we do a dot, sometimes what happens is we do 2.5 and we get a little lazy, just like I did there, and we'll put the dot and it gets a little low in our writing, and instead of looking like 2 times 5, it looks like 2.5 or 2 5/10. So it's a little bit, to use the dot, it's okay, but to be a good mathematician and use math grammar, math etiquette, I would suggest using the parentheses. Let's try my eraser here. Okay, erase that. All right. So it says 2 open paren 5 close paren, which means 2 times 5. That's a term, isn't it? That created a term in that position with the plus there. So I'm underlining that. The 2 open paren 5 created a term, and then the plus 3 open paren 4 plus 3 close paren, or another way of saying is 3 times the quantity of 4 plus 3. That is a term itself. That 3 times the open paren 4 plus 3 close paren, that creates a term. So again, we can do both sides of the plus sign and speed ourselves up a little bit with the order of operations. Let me switch back to black here. If you want to be a purist, you would go parentheses, so you'd look at the 4 plus the 3, and you'd do that first, and 4 plus 3 is 7. You would still keep your parens because you want to remind yourself that it's still times that 3. So you pull down that 3, and it's 3 times 7, or 3 open paren, 7 close paren. Pull down your plus. Now speed yourself up a little bit with that. You can still do that 2 times 5 because it's a term, and you have 10. So now you've rewritten 10 plus 3 times 7. Now we need to do the 3 times 7. So we have 10 plus 21, and 10 plus 21 equals 31. So now let's really get a little more complex with grouping symbols. We could have an expression that's 2 open bracket 5 plus open paren 30 divided by 6 close paren to the square root of 2 and then close bracket. So we now have, that's why I like to say grouping symbols instead of just parentheses, because once you use the parentheses, then the next set, when you compound them, is you need to use a bracket. And then if you've used a bracket, then you would use a brace. So what it's saying is, okay, we've got these grouping symbols with these brackets, so I need to look inside the brackets and start working in there first. Well, I've got 5 plus open paren 30 divided by 6 to the square root of 2, divided by 6 close paren to the square root of 2, and then close bracket. Inside of there, I've got to do the order of operations. So I need to do my parentheses inside of there, and that's 30 divided by 6. So now I'm going to have a 5, and that's going to still be in parens to the power of 2. And it's close. It's very important that you keep it in parens, because if we had a negative 5, we would want to remind ourselves that it's negative 5 to the power of 2. If you put the power of 2 without a paren just next to a negative 5, all you're saying the opposite of 5 to the power of 2. We'll talk about that later in future videos, but keep those parens. So you remind yourself it's that 5 to the power of 2. We pull down the plus, and we pull down the 5, and we pull down our brackets on the left and the right, and we pull down that 2 that we first started with. So now it reads 2 times bracket, open bracket, 5 plus open paren, 5 close paren to the power of 2, close bracket. Now within our brackets, we got to do our exponents. So 5 to the power of 2 is 25. We pull down the plus, we pull down the 5, we've got our brackets around that again, and we pull down the 2. So now it's saying 2 times the quantity of 5 plus 25, which in other words 2 times open bracket, 5 plus 25, close bracket. So we do 5 plus 25 is 30. And we again keep that either in the brackets or a paren to remind ourselves that the 2 is multiplying it times 30. And we pull that down, 2 times open bracket, 30 close bracket, and 2 times 30 is 60. So this one, a little more complex with having to look at some different grouping symbols and work from the inside out with your order of operations, and just keep pulling each next set of expressions down as it's simplified till you get down to the final answer. Here's another expression that uses the fraction bar which is a reminder that the fraction bar is a grouping symbol when you have a bunch of information happening on top of the fraction bar and a bunch of information down on the bottom. So in this case, I am writing 6 plus 4 in the numerator position, so it's 6 plus 4 all over that fraction bar, 3 squared times 4. So that fraction bar, you treat it as a grouping symbol until the end when you treat it as division. So you have to do everything on the top according to the order of operations in the numerator position, and you do everything on the bottom according to the order of operation in the denominator position. And then when you get down to just a numeral on the top and one on the bottom, then you simplify it using your fraction principles or division principles. So on the top we have 6 plus 4, that becomes 10. On the bottom we need to do the 3 squared because we have to do exponents first before we multiply, and that would then be 9, and we would have 9 times 4, which is 36. So we have 10 over 36. If you left that answer, it's not mathematically incorrect, but it's not simplified. And most likely on some standardized test, one of the choices is going to be 10/36, and another choice is going to be the simplified version, which means you can divide 10 by 2 and 36 by 2, and you end up with 5/18. That's the most simplified correct answer.